Hello everybody. In this lesson I will discuss a revolution or angles around a point, and we will look at the little theorem vertically opposite angles are equal, and we will discuss 6 examples. Now there's a theorem that says the adjacent angles in a revolution add up to 360 degrees. Now there's your protractor. And you can see that all the angles around this point, all of them, add up to 360 degrees. Now, when you want to use this theorem inside a rider, a sum, then the abbreviation that you may use could be angles around a point, or you can use angles in a revolution. So now you can see that your maths toolbox is growing. You already have the theorem angles on a straight line are supplementary, and now you can add another one, angles in a revolution. Now I want to explain everything about vertically opposite angles. Now, what are vertically opposite angles? Vertically opposite angles are the angles opposite each other when two lines intersect. Now, remember, when lines intersect, that means they cross each other. Now, when you go to the sketch, you will find the vertically opposite angles are angle A1 and angle A3. And there's another pair, A2 and A4. They are called vertically opposite angles. Now there's also a theorem. Vertically opposite angles are equal. And then the abbreviation that you may use in the exam is this, vert op angles equal. And that means vertically opposite angles are equal. So when you go to the first sketch on the left hand side, you find an angle that's 100 degrees. Then this angle over there, that angle is also 100 degrees, and your reason vertically opposite angles. And on the right hand side, there you find an angle that's 80 degrees, and this is the vertically opposite angle, and it's also 80 degrees. So now there's 3 items in your toolbox. Angles on a straight line, supplementary. Angles in a revolution add up to 360 degrees. And then the new one, vertically opposite angles equal. Example 1. Calculate with reasons the size of x, y, and z. And then you see the sketch there. There's 2 lines, they are intersecting, and then there's 4 angles around a point. And then there's one angle size was given, 100 degrees. And on the right hand side, you will see my little toolbox came with my 3 tools. Now let's see. You can start anywhere. My advice to you is to start where you find the known angle, and there's 100 degrees. So I suggest we start with this. Do you agree that angle Y and this known angle, they are vertically opposite? Therefore, we can say that angle Y is equal to 100 degrees, and the reason vertically opposite angles equal. Then, once you know the size of an angle, you write it on your sketch. Let's see. Let's go to X. Now, what is happening with X? Can you see X and Y? They are adjacent angles on a straight line. And we have a theorem that says angles on a straight line are supplementary, or add up to 180 degrees. Now, on the left-hand side, x plus y is 180. That's your equation. We know y is 100 degrees, so we substitute and then we solve x. Therefore, x is 180 minus 100 degrees and x is 80 degrees. I know the size, therefore it will fly in. Then the last angle I'm left with is this angle Z. Now, do you agree Z is vertically opposite to X? So we can say that Z is 80 degrees, vertically opposite angles are equal. But we can also work that one out by using the theorem angles on a straight line is equal to 180 degrees. Example 2. Calculate with reasons the size of A, B, and C. Again, on your sketch or your diagram, you find two intersecting lines and there's one angle given that's 35 degrees. So we always start with the given angle. Now, do you agree that angle B will also be 35 degrees? And the reason is they are vertically opposite angles are equal. And once you know the size of an angle, you write it in on your sketch. Then we can go to angle A. Now, do you agree that angle A and this angle, they are adjacent angles on a straight line? And we have a theorem that says angle A plus 35 is 180 degrees. Angles on a straight line equals 180. Then we can solve for A. So the 35 will walk across and we end with A is 145 degrees. And once we know the size, we add it on our sketch. Then the last thing we need to work out is, let's use a green, is this angle at C. So what can you see? C is equal to 145 degrees. Why? Because that angle at C is vertically opposite to angle A. And you can also work out C by using the reason angles on a straight line is equal to 180 degrees. Example 3. Calculate with reasons the size of J, K, L, and M. Then on your diagram, you find three intersecting lines and then there's two angles given. The one angle is 46 degrees and the other one is 72 degrees. Now you can start anywhere. Always start with the given angle. So I will start with this angle 46 degrees and K is equal to 46 and your reason vertically opposite angles equal. Then you add the angle once you know the size. The next angle is angle M and M is 72 and the reason why I can say that is angle M is also vertically opposite angles equal, but now it's vertically opposite to 72 degrees, the other angle. Then, once you know the size, the angle will fly in. We can now have a look at angle L. And do you agree that angle M plus L plus K, they are equal to 180 degrees since they are adjacent angles on a straight line is equal to 180 degrees. They are supplementary. Then we know M is 72 degrees plus L, that's what we're looking for, and then K is 46 degrees equals 180. Then 72 plus 46 is 118, and then to solve L, we end with 180 minus 118, and then L is 62 degrees, and then you write it on your sketch. And then to find J, do you agree this L and J will also be 62 degrees, and your reason, vertically opposite angles equal. Example 4. Calculate the value of x and b1. Now when you go to your sketch, there's two intersecting lines, and then there's b1 and there's b2. So we can say, now have a look at this. Do you agree? They are vertically opposite angles, and we know that vertically opposite angles are equal. So we can say that B1 is equal to B2, and our reason, vertically opposite angles equal. And then in the place of B1, we substitute x plus 30, its size, equals, and B2 was given that it's 110. And now we can solve x. Therefore, x is 110 minus 30. X is equal to 80 degrees. And then the other one we were looking for was B1. And then, do you agree? B1 is equal to x plus 30. That was given. And in the previous sum, we worked out x's value was 80. Therefore, B1 is 80 plus 30 is 110 degrees. Example 5. Calculate the value of y. So when you go to your sketch, again, there's two lines intersecting, and then we find this angle 24, and vertically opposite to that angle is the 2y plus 16. And our theorem says that vertically opposite angles are equal. So we can say that the 2y plus 16 is equal to 24 degrees. And remember, you have to add your reason. Vertically opposite angles equal. And then we can solve y. So we end with 2y is 24 minus 16, which is 8. And then we don't want 2y, we want y. So we will divide both sides by 2. Therefore, y is equal to 4 degrees. Example 6. Calculate the size of K1 and K3. Now before we start, I want to focus your attention on this little symbol over there. Can you remember from the very first lesson, I said that means the two lines are perpendicular. In other words, there's a right angle, a 90-degree angle. And when you go to your little toolbox, you will also see I added it there because it means something if you see that symbol on your diagram. So then we can start by saying that angle K1 plus K2 is equal to 90 degrees, and that was in fact given. That's your reason. So we know that K2 is 40. We substitute in K2's place, and then we will solve K1. So 90 minus 40, and therefore K1 is 50 degrees. Once I know the size, I write it on my sketch. Then, if you go back to your sketch, you see that there's a straight line, and then there's 4 adjacent angles on a straight line. So therefore, we can say that K1 plus K2 plus K3 plus K4 is equal to 180 degrees. And your reason? Angles on a straight line equals 180 degrees. They are supplementary. Now we can substitute. K1 is 50 plus K2 is 40 degrees plus K3 is what we're looking for plus 15. K4 was 15 equals 180. And now we will say 50 plus 40 plus 15 is 105. And then we can solve K3. So the 105 will go to the other side. It becomes negative. 180 minus 105 is K3 is 75 degrees. In the next lesson, I will discuss the transversal line and the types of angles that you can find there. Click on the video in the left-hand corner to take you straight to the next video.